So how do we arrive at the power rule? Let's take an example x squared. So we have x times x. We're going to add in delta s over here. So when we add in delta s, we're going to be getting these two rectangles and this square over here. And when we express that algebraically, we get this. And we're going to be getting, of course, two rectangles over here. So since the derivative is rate of change, we're going to be dividing by delta x. So far we've calculated delta y over here, which is a change in y, which is these two rectangles and a square. And by dividing by delta s, we're going to be getting that rate of change. And we get 2s plus delta s. Since delta s is approaching 0, this delta s term is basically not going to matter. So we're going to be left out with 2s. So if we look at the procedure, the general procedure that we did here, it can be expressed as Leibniz's derivative notation over here, where we have the function of s plus delta s minus the function of s all over delta s to find our rate of change. Right, let's take a look at a harder example. So here we have a cube, and if we imagine it, we have the x cubed in the back over here. Then we have three faces of x squared times delta x, and then we're going to be getting these three bars and finally this cube of delta x cubed. So we're going to express it here, and here we're going to see those three faces, three bars, and then one tiny square. Cube, I mean. So since this is our delta y, we're going to be dividing it by our delta x to find the rate of change. And we're going to get 3x squared plus 3 delta x plus delta x squared. Again, the delta x doesn't really matter. So we're going to be left with 3x squared. So you can see the power rule in action in this case. So with x squared we had s squared, and then we move that 2 over and then subtract 1 from it, so it becomes 2x to the 1 first power, and that's basically 2x. So when we think about it, we can think of it as expanding in these dimensions. So s squared is going to be expanding in this dimension and this dimension, and x cubed is going to be expanding in all three dimensions. So that's where we get why we see a 2x when it comes to x squared, since it's expanding in two directions.